Assalamualaikum warahmatullahi wabarakatuh. My name is Mohamad Amirul Ashraf bin Zaki. Metric number 1717357. Okay, my supervisor is Dr. Siti Atika binti Cik Rahman. Okay, for the FYP2, my title is Wind Tunnel Simulation of Wind Pressure on a Rural House due to the effect of neighboring buildings arrangement. Okay, let's go for the intro first. Okay, the intro, there are two elements. Okay, the first one is problem statement. Okay, windstorm is one of the natural disaster that always occurred in Malaysia. Rural house is the type of house that always suffer severe damage from windstorm. Yeah, because they made it made from it made of timber or combination of concrete and wood. Okay, because of this, the rural house usually will receive severe damage from the windstorm. Okay, the unique and traditional design of rural house that consists of overhang and additional kitchen house may affect the cost of the roof blown of the issue. Okay, the next one is objective. Okay, the first objective is to study the wind flow visualization on the rural house due to the arrangement of neighboring buildings to generate the pressure coefficient around the rural house by using wind tunnel test. And the last one is to determine the optimum arrangement of neighboring building around the rural house in preventing severe damage during the windstorm. Okay, next for the past research. Okay, this is the past research that has been done previously. Okay, Chow ETL, Wang ETL, Chamerone, and Lalonde Cook. They focus on the neighboring building. Their research on the neighboring building. Okay, Wang ETL, Lalonde and Cook at the wind direction. Choi and Kwon on the blockage sheet fact. And for the roof page, Daraman ETL, Kim ETL. And last one for the creating of wind profile, Kozma and Lashka, Liu and Kim ETL. Okay, what is the gap of this research and previous research? Okay, study by Wang ETL is on the neighboring building on scaffold. And Cho ETL study about the effect of neighboring building too, but it is on the high-rise building. So this research study on the effect of neighboring building on the low-rise building of rural house. Okay, study from positions that are on rural house, but there is no additional kitchen house. So this study use additional kitchen house at the center. And Raman ETL study on the effect of present kitchen house on wind pressure, single wind flow direction and angle that is 0 degree. Kozma and Laska, Chang Emerone and Choi TAL also use Pirates or as known as vortex generator in their research. Wang ETL, Kozma and Laska, Chang Emerone and Choi TAL use neighboring building same size and shape with magic building, but this study use neighboring building that smaller than the magic building, smaller size. Okay, for the methodology, okay, there are three subtopic. There are three stages. Okay, the first one is data collection. Okay, data collection from previous research by. Okay, this is the data collection from previous research by Draman ETL. Okay, data collection is very important in order to build and develop the rural house model. Uh, but since the MCO movement control order has been reinforced by the government, so the site investigation cannot be done. So the data was obtained from previous site survey by other researcher. Some useful data from post-windstorm site survey by Draman ETL has been used in the making of the rural house. Okay, this is the data. Okay, this is the dimension for the brain building. Okay, this is the dimension of typical rural house. Okay, the model has been scaled down by 25. Okay, so the dimension of model that has been used is 48 cm for length, 32 cm width, and 60 meter for height of the kitchen. Okay, 27, 27 degree of roof pitch, 1 meter of overhang, and 1 meter of gap height were chosen because they are the critical element that will make the rural house become more vulnerable to windstorm. Based on research by the Raman ETL. Okay, okay, this is the 3D schematic diagram of model. Okay, the kitchen house, as you can see, the kitchen house is at the center of the core house. Okay, the next stage is development of model. Okay, this is the process of mounting silicon tube. Okay, the silicon tube is connected to the pressure node. This is the pressure node, pressure node, pressure node. Okay, there are 22 pressure node uh, that has been installed at the roof. Okay, this is the location. This is the location. 22. Okay, okay. From the wind flow, this is the windward side and this is the leeward side. Okay, there are two action that occur at the roof. The first one is pressure. Pressure, the roof will go down and the suction will the roof will uplift. Okay, and the last stage is wind tunnel test. Okay, the wind tunnel test start with the setup of rural house model with arrangement of case one in wind tunnel test. Okay, and then set up the voltage generator in, at the inlet of the wind tunnel. Okay, as you can see, this is the voltage generator, the red one. Okay, and after that, set up the wind speed to 26.4 meter per second, and then run the wind tunnel test and collect the pressure data. After that, decrease the wind speed of wind tunnel to 10 meter per second to conduct flow visualization on the model. And then repeat the step for case 2 and case 3 of measurement of neighboring building. Okay, this is the picture of wind tunnel that has been used in this research. Okay, this is the arrangement that's been used. The first case is when the neighboring building is at the site 150 millimeter at the side of neighboring building. Second one is the case 2 is the neighbor building is at the front of main building 150 millimeter at the front of the main building. And for the case 3, the neighboring building located at the site 150 meter at the side of the main building and 150 millimeter at the side of at the front of the main building. Okay. Okay. Let's go for the result and analysis. Okay. The this is the graph from the result. Okay. From the graph, uh, it can be seen that most of the value of pressure coefficient are negative. It means that more suction occurred at the house roof compared to pressure, and only two positive values of CP pressure coefficient from each cases. Uh, it, uh, it means that less pressure behavior occurred at the roof compared to the suction. Okay. Negative means suction. Negative value means suction, and positive value mean pressure. So more negative value so means more suction occur at the roof. This happened because of the obstruction in front of the house model that has been installed at the inlet of the wind tunnel. Okay, the pattern for case 1 and case 2 is the same, where for the first three node, the the value of CP decrease, after that increase, and then the value is about the same, and then dramatically decrease and significantly increase in value, and then decrease. But for arrangement for case 3, a little bit different at the beginning and at the at the last node, where the node is uh, opposite of the case 1 and case 2. Okay, from the graph, we can see that the highest section occurred at case 3 with CP of negative 2.259. The highest pressure occurred at case 1 with CP 2.83. Okay, neighboring building affected the windward side more than the leeward side due to the shielding effect, and it caused the turbulence to interfere the well-organized vortex shedding formation in the main building, and the this this turbulence can either increase or decrease the wind pressure of the main building. Okay, this is the wind flow visualization that has been done. Okay, this is the wet region due to the roof, the house. Okay, this is the wet region after due to the upstream of the neighboring building, and this is wet region. Okay, the air, the wind will recirculation after hit the neighboring building. Okay, for the conclusion, okay, the first one is when the wind flow hit the neighboring building, the air will recirculate and some of them will produce wet region. The turbulent flow at the wet region generated in the downstream neighboring building can either reduce or increase the wind force of the main building. The closer the neighboring building and the major building, the higher the shading effect and even negative force can be generated. Okay, for the second conclusion, based on second objective, more section occurred at the roof house than pressure behavior. And the last one is optimal arrangement of neighbor building should be case 2 because it has balanced pressure with CP 2.179 and suction CP negative 1.997. occurred around the roof house rural model. Okay, rural house model in this case will experience the least damage during the windstorm. Okay, that's all from me. Thank you.